Have you ever wondered what causes the magical northern lights? The northern lights, or as the scientifically inclined might call them, Aurora Borealis, have been casting a mesmerizing glow across the night sky for centuries. This ethereal spectacle with its waves of green, purple and red lights has sparked fascination and wonder across cultures and epochs. From ancient Inuits who saw them as the spirits of their ancestors dancing in the heavens, to the Norse who believed they were the radiant bridals of the Valkyries, the northern lights have been the protagonist of countless stories, myths and legends. But behind this enchanting display lies a fascinating scientific explanation, one that involves the sun, the earth and a cocktail of gases. Yet, it doesn't make the view any less magical. Rather, it adds another layer of awe to the grandeur of our universe. Now, let's unravel the science behind this celestial ballet. The story of the northern lights begins with the sun. The sun, our star, is a bustling cauldron of nuclear fusion. Every second, it converts millions of tons of matter into energy, creating an intense heat that radiates out into space. But the sun doesn't only emit light and warmth, it also produces a stream of charged particles known as the solar wind. Imagine the solar wind as a steady breeze blowing from the sun, carrying these charged particles across the vast expanse of space. Traveling at 1,000,000 miles per hour, these particles speed towards Earth, a journey that takes about 2 to 3 days. Now, picture Earth, with its invisible magnetic field extending out into space. This magnetic field acts like a protective shield, deflecting most of the solar wind. But at the Earth's poles, the magnetic field is weaker, allowing some charged particles to enter our atmosphere. This is where the magic happens. As these particles collide with the gases in our atmosphere, they transfer their energy to these gases, exciting them. This excitement isn't quiet or subdued, but rather a vibrant display as these gases then release this energy in the form of light, creating the phenomenal spectacle we know as the Aurora Borealis or northern lights. But why at the poles, you might wonder? Well, the Earth's magnetic field lines converge at the poles, guiding these charged particles towards the north and south poles like cosmic pathways. This is why the majority of auroras occur within a band known as the auroral zone, which is typically around 3 to 6 degrees wide in latitude and between 10 and 20 degrees from the geomagnetic poles. So, the sun and the Earth's magnetic field are the main actors in this cosmic play. But what about the colors? The northern lights are not just a light show, they are a color show too. You see, it's not just about the interplay of the sun and Earth, but a delightful dance of gases that paints the sky in a myriad of hues. The colors of the northern lights are a direct result of the types of gas particles being excited by the solar wind. Oxygen, for instance, when excited by solar particles, emits a bright green light, the most common color we associate with the northern lights. But oxygen isn't just a one-trick pony. At higher altitudes, it can also produce a rare all-red aurora. Nitrogen, on the other hand, adds a touch of blue or purplish red to the mix, depending on the type of nitrogen and the altitude of the collision. So it's not just the sun and Earth putting on a show. It's a cosmic ballet of light and color, orchestrated by the sun, performed by gases, and viewed by us. The northern lights are a spectacle that combines science, nature, and art into a stunning display. We've journeyed together through the cosmic ballet that gives birth to this celestial masterpiece. The sun, our celestial maestro, sends out solar winds, charged particles that journey through space. Upon meeting Earth, they interact with our planet's magnetic field, spiraling towards the poles. This is where the magic happens. The Earth's atmosphere, like a grand canvas, welcomes these particles. Different gases present in the atmosphere interact with these solar winds. Oxygen gives us the ethereal green and sometimes rare red lights, while nitrogen gifts us the brilliant blue and purple hues. This interaction, this dance of particles and energy, is what paints the night sky with the Aurora Borealis, a spectacle that's as scientific as it is artistic. So the next time you gaze up at the night sky, remember the intricate dance of particles and energy that brings us the magic of the northern lights. Until next time, keep looking up.